Class, let's go ahead and prep for this Chapter 8 test, going through lessons 1 through 8.8. First one, identifying characteristics of a quadratic function. Identifying the characteristics of the quadratic function and its graph. We can see over here that it has an axis of symmetry of, well, this is 2, then this must be -2. That would make this -1, right? So the axis symmetry is -1, and we know the axis then has to be at, looks like if this is -2, then this would have to be -4. So I'm going to say -1, -4. All right, there we go. That's the vertex, and our axis of symmetry is -1. Next, we can go ahead and start knocking out the other things. We can see that we can also determine that the domain, all right, is going to be all real numbers because these arrows go in this direction infinitely, even though it's going to be at a very big slight arc, it is going to go forever, so that's going to be all real numbers. The range is going to be from -4, right? Well, all the numbers including -4 and above. So if it's -4 or greater, it's in the range. Function is decreasing when x is less than -1, right? Less than -1, it's going down. That means it's increasing when it's greater than -1. We also know that the x or the y-intercept is -3, and the x-intercepts are -3 and 1. We also know that as y is, well, I'm sorry, the function is positive. Let's see, the positive numbers, right? When x is less than 3 or less than -3 or greater than 1. That means they're negative when it's greater than -3 and less than 1. Okay? I know that is going to be, as x is going to -infinity, y is going to positive, so it's probably going to say as y is going to positive, x is going to negative, and as y is going positive, x is also going to positive, right? Y is going to positive, x is going to negative, as y is going to positive infinity, x is going to positive infinity. All right. So let's go ahead and go to, that was number 1. Let's get ready for number 2. On number 2, we see we have g of x is equal to 5x squared. This is easy, really. It's just putting a number in here and making a table. So the first one I'll make is 2. So this is 2 squared times 5. This is really going to be 5 times 4, right? And we also know that works for a -2 because a negative times a negative is a positive. So either way, we're going to have at -2 when x is -2 or when x is 2, we're going to have the answer is 20 because 5 times 4 is 20. Okay? And then let's just say we put 5 at -1, x is -1. And -1 times -1 is 1, so it's 1 times 1. Now we got 5 times 1, and that's 5. So when we got -1 for x, it's going to be a 5, which means when we have 1 for x, it's going to be a 5. And now we can go ahead and pop in 0. Well, that's easy because 0 times 0 is 0, and 0 times 5 is 0. So when I get 0, I'll get 0. Now we can make our table, and you'll see in our table we have -2 is 20, we have -1 is 5, 0 is 0, 1 is 5, and 2 is 20. Now we can plot those coordinates, right? And when we do, we see we're going to have a parabola here, okay? And this parabola is going through 0, 0, -1 and 5, 1 and 5, -2 and 20, and -2 and 20, excuse me. All right, let's go to B. B, I already did the work for. You see that when we've got 1/3 x squared, we can again replace that x with, well, we're going to go with the denominator, factors of the denominator. So the first one we'll go is 3. We know 3 times 3, right? 3 squared is going to be 9. 9 times 1/3 is 3. So we can say that when x is 3, then y will be 3. Now we're going to try 1. And we know that, well, -1, whether we have a -3 or a +3, that was going to happen, right? So we can come over here and put +3 as well, will be 3. Now we're going to go to -1. And whether we do -1 or we do 1, we're going to get the same answer, because we know -1 times -1 is 1, and 1 times 1 is 1, and 1 times 1/3 will give us 1/3. And then, of course, again with 0, we could say, if we put 0 here, 0 times 0 is 0, 0 times 1/3 is 0. So now we can put a table with these coordinates in it. And as you can see right there, we use -3, -1, 0, 1, and 3. And we got our answers, 3, 1/3, 0, 1/3, and 3. We plot those coordinates. And we see 0 is going to be at 0. -1 will be at 1/3. -3 will be at 3. I'm sorry, -3 will be at 3. Sorry about that. And that means that 1 and 3 will be 1/3 and 3 as well. And now we just make our line that makes our parabola. All right, let's go to number 3 now. Number 3 says graph the function. If I graph this function, I know I have x squared, and let's just face it, x squared is going to be, well, let's just say we have -2, we have -1, we have 0, and 1 and 2. Well, this is just going to be -2 squared, right? So that's going to be 4, which means 2 squared will be 4. And then -1 squared, well, that's going to be 1, which means 1 squared will be 1, and 0 will be 0. But now, because we have this -5, and it's not a parentheses around here, that means this is going down 5 units on my coordinate plane. So all the points that were there are going to go -5. So instead of 4, this would be at -1. Instead of 1, this would be at -4. This will be -5. This would be -4. And this would be -1. And if we follow this out, we're going to see we have, yep, there's our points. When x is 2, we got -1. When x was 1, we got -4. When x was 0, we got -5. When x was 1, we got -4. And when x was 2, we got -1. We plot those out, and we do get the same parabola 5 units down from the original. All right, let's go with B. This time we're adding 3, which means instead of going down, we're actually going to go up 3 units. And we're going to have the same parabola that we start with these same y values, right? But this time we're going to be adding 3. So instead of 4, 4 plus 3 is 7. Instead of 1, 1 plus 3 is 4. Instead of 0, 0 plus 3 is 3. And instead of 1, 1 plus 3 is 4, and then we get 7 again. So our new y values are going to be these numbers here. And let's go ahead and see how we did on our graph. You can see when we're at -2, we got 7. When we're at -1, we got 4. 0 was 3. When x is 1, we got 4. And when x is 2, we got 7. And we make our parabola. We take those 0 and 3. So 0 and 3. -1 and 4. -1 and 4. 1 and 4. 2 and 7. and negative 2 and 7. And that's how we make our parabola. Let's go to number 4 now. It says graph the function. To graph this function, we have to remember a few things. One of the things was, since we have a quadratic equation, we can go and say, well, I'm going to remember that I use negative b over 2, okay, and 2a, excuse me, and that's going to give us our axis of symmetry, okay, axis of symmetry. We could remember that the coefficient in front of my first exponent, right, exponential power is a, the second one is b, last one is c. We can also remember we'll probably cross into 2 on our quadrant. But let's go ahead and get our axis of symmetry. Remember, negative b is going to be negative 10, so we have negative 10. And then we're going to be putting that over 2 times negative 5. And when we solve this out, we get a negative 1. You see right there, we got negative 10 over 2 times negative 5. That gives us 10 over negative 10, which is negative 1. I'm going to put this negative 1 in my formula for x now. See how I replaced x with it? And when I solve it, I get 3. So that means my y value will be 3. So now I have my vertex. My vertex is going to be negative 1 and 3. All right, we also know that we're crossing through negative 2. Here's negative 2 on my y-axis. So now I started with negative 1 and 3, right? Negative 1 is here and the 3 is here. I made sure I crossed through 2. So if I'm using my knowledge of parabolas, this was 1 away and it went down from negative, or I'm sorry, to 3, or sorry, to, see, it went down to, oh, that was my vertex. I'm sorry, negative 2, right over here, negative 2. And so we're going to have negative 2 on the opposite side at 1 as well. If I wanted to, I could probably pop in a couple other numbers in here and get my y value. Instead of putting 1, I could always put 2 in place of here, or 3, and then find out what I got for y. Okay? Let's move on. This one I showed some of the work, so let's go on. It says that the graph of g to x, g of x, equals negative 2 times x plus 2 squared plus 3. So we're going to use our knowledge again. This tells me I've got x plus 2 squared. This is going to be my x value, but I have to go ahead and put it to 0. And that's what I did over here. I put x plus 2, right, equals 0. And that gave me x equals negative 2 when I solved for it. All right, now that I did that, I also remember that the 3 here, right, is going to be the y value. When I take this to negative 2 now, okay, I have negative 2 over here. I've got my axis of symmetry because if x is negative 2, right, I can solve this for y by plugging in negative 2. Right? I know that my h is negative 2. That's what we said right here. And we know that the y value is, y-intercept is going to be 3, right? So to that vertex. So we've got negative 2 and 3 for my vertex. So right over here, we're going to go to negative 2 and then go up 1, 2, 3. That's going to be my vertex. Now, I'm going to go ahead and solve this. I see that I'm 2 away from here, so if I want to, I can be 2 away here to negative 4. I'm going to plot 2 more. I'm going to go with negative 4 for my first one. So when g is negative 4, I'm just going to work that out really quick for you. So if remember I'm solving this problem having negative 2 times x, and we're saying x is going to be -4 now, right? We're plotting something for this coordinate, okay? And then, well, in this for x, and we're seeing where it lies now. And it's going to be -4 plus 2 square plus 3, all right? When we do this, we see that we're going to get -2 times -2 squared plus 3. I know that -2 times -2 is +4. Now we have 4 times -2 plus 3. And now we're going to take 4 times 2, that's -8. -8 plus 3, well, that's -5. So now we know that when x is -2, y is going to be -5. I'm sorry, when x is -4. Just wrote that, should have been -4. And y will be -5. So that's a coordinate. So I can pop that in. Let's see, -4, and then -5 will be about right there, right? And then, let's see, we can also pop in -3, right? And if I did the same thing, this time I would get, I guess I'll work it over here, -2, and then I have -3 plus 2, plus 3, and that's going to give me a -1. Sorry, this is square. -1 squared is 1. So now I got -2 times 1 plus 3. That's going to give me -2 plus 3. That's going to give me 1. So I know on this one, when x is -3, y will be 1. So I could say, come to my graph at -3, y will be 1. So now I'm going to have a dot here, one here, and then I have one about here. Let's see if that's where it leads me. Says right there, reflect the points, right? Once I've got those coordinates, -3 and 1, -4, -5, I reflect the points, and that's going to give me those dots there that just came up. And then I just make my line, and there's my parabola. All right, let's move on. Graph the function. I showed the work over here to get it quicker. G of x equals -x squared minus x plus 12. Once again, I'm using my formula for my axis of symmetry, -b/2a. This time b will be -1, because if there's nothing, there's at least a 1 there. And that's going to be b. And a will also be a -1. So -1 times -1 is 1, 2 times -1 is -2. My axis of symmetry is -1/2. I'm going to plug that into my problem. When I work it out, I'm going to get 12 and 1/4. So my vertex should be -1/2 and 12 and 1/4. So once I've got my axis, or my vertex there, then I'm going to go ahead and remember that I'm crossing through +12. So I can make another point here and another point here to reflect off of it. Then I can find my x-intercepts by remembering that I can factor out my negative sign. That's going to leave all my signs the opposite. This will become x squared plus x minus 12. I will say, what numbers make up -12? Well, I know that -12 can be made by -3 times 4. And 4 minus 3 will give me a +1. And that's what I needed there. So x minus 3 and x plus 4 will be my two binomials that I can make from this. And then I would solve them for x, putting them both to 0. Now give me x equals 3, and that's why we have it 3 here for one x coordinate, and x equals -4. And that's why we have -4 for the other. All right, let's go to number 7. So write a quadratic function in standard form that models a table. Well, I'm seeing over here I got 12, 6, 4, 6, 12. This definitely is quadratic. I know it's going to make a parabola. The first thing I can say is, well, I've got -2 and 4 make my vertex, right? So now that I got a vertex of -2 and 4, I can use my equation in vertex form, which is a times x plus 2 squared plus 4. Now, I'm going to put the opposite. This should have been just a like everyone understand it, the form should have been A, and then it would have been X plus, I think it's H, and then plus K. So -2 is going to be my H, and since it's, I'm sorry, that should have been negative. I don't know why I put a positive there. There we go. And then a negative times a negative makes that positive that's there. There's no need to solve for X over here, so it stays a positive 4. All right, so that's why the -2 becomes a positive 2. Once I've done that, it says I can go ahead and look for where X is 0, and it's 6. So I'm going to replace X with 0. So my formula, X is now 0. And f of X, which is Y, will equal 6. And then I'll solve it. 2 plus 0 is 2. 2 squared is 4. 4 times A is 4A. And now I have 4A plus 4. I'm going to subtract 4 from both sides to combine my like terms. That's going to give me 2 equals 4A. Then I'm going to divide by 4 from both sides, and A is going to equal 1/2. So my formula would be 1/2 times X plus 2 squared plus 4. I'm going to convert it to standard form, because that's what it says. I'll write it in standard form. And that simply means once I have my formula, I'm going to go ahead and solve it. Well, X squared plus, or X plus 2 squared plus, times X plus 2 squared, in case you can see where I got that, X plus 2 times X plus 2. 2 plus 2 is 4. 2 times X is 2X. Put the 0 here. We got X plus times 2, that's 2X. And X times X, that's going to be X squared. And now everything comes down, X squared plus 4X plus 4. Now you can see where they got this right here. All right, now they're going to go ahead and multiply everything to 1/2, distributing that property to everything. When I do this, I'm going to have 1/2 X squared plus, well, 1/2 of 4 is 2. So that would be plus 2X plus 2 plus 4. Well, 2 plus 4 equals 6. And now we have our standard formula. F of X equals 1/2 X squared plus 2X plus 6. All right, let's go to number 8. Number 8 says write a quadratic form, function in standard form. Because they gave me 2 x-intercepts, I can write this in intercept form. That intercept form is going to be A times x minus p times x minus q. Well, when we do this, I know that my p is going to be -5, which make it a negative times a negative is a positive 5. And my q will be 4, so this would be a negative times a positive, that's a -4. Now that I have those numbers there, I can take 3 and -16. I'll make x 3, and I'll make f of x, which is y, -16. All right, now I'm going to solve it. 3 plus 5 is 8. 3 minus 4 is -1. 8 times -1 is -8. -8 times a is -8a. When I divide -8 away from both sides, I get a equals 2. I'm going to rewrite this to show a now is 2. 2 times x plus 5 times x minus 4. Now I can simply solve it. First, I'm going to go ahead and FOIL these, or I could have multiplied them together like we did before. We got 5 times -4, that's going to give us -20. We're going to have x times x, that's x squared. We're going to have a 5x plus a -4x, which makes an x, right? Let's see, 4x, yeah, -4x, positive 5x, and that's going to give me my positive x. They were showing us how we got -4x plus 5x, and then they combined it. Now that I've got that, I'm going to multiply 2 to everything. That gives me 2x squared plus 2x minus 40. All right, let's go to number 9, using interpreting the average rate of change. If I use this, I'm using network A, which is a table, and then network B, which is a graph. Right? I can look over here and see that the 2 social media networks open their membership to the public. Compare the network membership by calculating and interpreting the average rate of change from day 10 to day 20. Day 10 was 1,400, day 20 was 2,150, which means I can take 2,150 and minus 1,400 and put it over 20 minus 10. This is going to give me 750 over 10. 750 divided by 10 is 75. So the average rate of change from day 10 to 20 was 75 for network A. Next, I'm going to look at this graph. Remember, we're going with day 10. That's not quite at 900. I'd say maybe about 850. And then day 20. And that's going to be about, looks like 1,800. So I'm going to take 1,800 minus 850 and 20 minus 10. And that's going to give me 950 divided by 10, which is 95. That means the average rate of change for network B from day 10 to day 20 was 95. So from day 10 to day 20, network A's membership increased by an average rate of 75 people per day, and network B membership increased at an average rate of 95 people per day. So network B's membership is going faster from day 10 to day 20. All right, next we've got I have to erase some of this. Sorry. I guess I could have done that by just that. All right. And now we're going to work these. It says plot the points, tell whether the points can be represented by linear, exponential, or quadratic. All right. So let's look at the first one. The first one has -2 when it goes to 0. That's increasing by 2. When it shows 0 to 1, that's increasing by 1. When it shows 1 to 2, that's increasing by 1. It shows 2 to 4, that's increasing by 2. All right. And then over here, we see that we had 4 to 0, that's an increase of 4. It's actually minus 4, sorry, subtracting 4. Minus 4. And over here from 4 to -1/2, it went down by, went down -1/2. And then from -1/2 to 0, went up 1/2. And then from 0 to 4, it went up -4. Actually, positive 4, right? Positive 4. So now you might think, wow, those don't make any pattern at all. But let's look at this again. We see that we have from, we got 4, let's see, 4 to 1/2. We got -1/2 to 1/2. And then we've got to +4. And we can see that this is going to be quadratic, right? Because we know that it's showing a reflective side of each one, and it shows a vertex. So we can say then that if we had, let's see, well, this is from 2 and 4. If this was going to be an increase of 1, it would have been a 1 over here, and this probably would have been a 2 then, right? So I'm just, if this was adding -1, and this, there would have been a 1 here. So we got 2 over, well, let's just look at this. We got 4 and 1/2, okay? And that's a decrease of, it's an increase of, it's like 3.5, right? And then you've got 2 over that. Well, without going into the division part of it, I erased all that because I realized that plot the points kind of made it easy. Once you plot this, you realize that you're dealing with a parabola, which gives you a quadratic equation, right? You got -2 and 4, you got 0 and 0, you've got 1 and -1, 2 and 0, and 4, which gives you that parabola there. This is quadratic. Next, we can see that if we plot these, I think we're going to see a line. Let's just look at this really carefully. If we're minusing or adding 2 to this one, we're adding 2 to this one, we're adding 2 again, and we're adding 2 again. And over here, we are adding 3. Once again, we're adding 3, adding 3 again, and adding 3 again. So this is constant rate of change. That tells me this is a linear equation. Linear. All right, the points can be represented by a linear function. All those points make a straight line. Then over here, we can look at this, and we can see that this is getting multiplied, not added across at all, but multiplied by, looks like 2, because 2 over 2 is 1, so times 2. And then multiplied by 2 again, and then multiplied by 2 again, and then multiplied by 2 again. This is exponential growth, so this should be an exponential function. Okay, you can tell the different ways that they look. Quadratic looks like a parabola, linear is a straight line, and exponential is just kind of looks like a line bending and going, following one of the axes, X or Y axis, and then going up toward another. That was all of them, so I hope this helps you prepare for the test. Good luck. See you in class.